Hello students, welcome to the next lecture on the real analysis. Today we will discuss about limit comparison test for the infinite series here. Myself, Dr. Garg. You can simply follow my YouTube channel Dr. Harish Garg where you can find various videos on the topic sequence and series and as well as real analysis. So what we have discussed in the last lectures, we have discussed the three tests, nth term test, nth partial and the geometric test in our previous lectures. Now we will discuss about this P test and the limit comparison in this lecture with the help of 10 to 12 illustrative example. What is the limit comparison test? First of all, so if you have any of the two positive term sequence, what is the meaning of the positive term sequences? That is an is greater than 0 for all n as well as bn is greater than 0 for all n. Then there are the three different form of the limit comparison test. The first form is if you take the ratio of the an and bn, it comes to be say L. Depending upon the nature of this L, if L is my non-zero and the finite number, then the behavior of this an and the bn are same. What is the meaning of that? If you prove that bn is convergent, then an is also convergent. If you prove bn is divergent, then an is also divergent. If L is my 0, because here is a non-zero, so if L is 0, then whatever you have taken the denominator, if it converges, then the series an is also convergent. If L is my infinite, L is my infinity and bn is my divergent, then an is also divergent. All the other cases, if it happens, then called as the divergent series. What is the limits? Second form of the limit comparison test. So if you take any of the positive number beta, and if you prove that an is less than of beta times of this, then depending upon the nature of this bn, if it is convergent, then an is also convergent. However, if this sign is changed to be the greater than sign, and if you prove bn is divergent, then an is also divergent. The third nature of this comparison test is if you take the ratio of an plus 1 upon an and bn plus 1 over bn, and if you prove that this bn is convergent, then an is also convergent, while if you prove it's a greater than, then it's a divergent. This is the limit comparison formula. And this is the test related to the P test. This is a very important test and very useful when you compare the convergence of the infinite series. What is the limit test? What is the P test says? If you have the series of the form 1 by n raised to power p, then it converges whenever this p is greater than 1, like n square. You can see this 2 is greater than 1, so this series is convergent. We all know that this is a divergent. Why? Because there is 1 and p is equal to 1, it's a divergent. So let's prove that. We will consider three cases. The first case is when p is greater than 1. Then I can write here. So I can write also in terms of this. Now since p is my greater than 1, what is the meaning of that? 3 raised to power p is always be greater than the 2 raised to power p. Or you can say 1 upon 3 raised to power p is less than of 1 by here. So this number is less than of 1 by 2 raised to power p. Similarly, 5p is greater than of the 4p, 6p is greater than of the 4 raised to power p, and so on. So I can write this number as less than of this and so on. So what is this term is? That is a 2 upon 2 raised to power p. I can write this as 1 over 2 raised to power p minus 1. What is that? This is 4 over 4 raised to power p. So I can write this number as p minus 1 and so on. So I can write like this way. So do you know which is that? Yes, this is the geometric series which can be written like here. So once it's a geometric series, then you can apply the geometric series test with the common ratio is my less than 1. So once it is a less than 1, then we can say it's a convergent series. On the other hand, if you consider p is equal to 1 and the p is less than 1, so what will happen if p is 1? So this an is my 1 by n, and we know that the 1 by n is a divergent series. When p is less than 1, what is the meaning of that? np is less than of the n, and it implies 1 upon np is greater than 1 by n. So that clearly proves that 1 by n is my divergent. So by the limit comparison test, this is a divergent series. Now what are the applicability of this P test and the limit comparison test? So what you conclude that any of the series which of the form 1 by n raised to power p is convergent only if p is greater than 1 and divergent here. So let's discuss the 12 different kind of the examples so that you are able to understand more clearly. Now look about that. So let's start with the first one. So this is my ANR. Your always target is to find the value of Bn. How you find the value of the Bn? So that's a very simple. What is the highest power of the n in the numerator? That is my n. What is the highest power in the denominator is n cube. So what is the Bn is my n square. Look at that. If you take this, what is the highest power of the n in the numerator? That is n. What is the highest power of the n in the denominator? That is of this. So which is nothing but my, here is my Bn. So if you look about this example, so Bn is my 1 by n square. Then find the ratio of the An upon Bn. So what will happen if you open them? This is Pn square plus Qn cube divided by here. So which is clearly says that it's a infinity by infinity form. So you can take divided by n cube on both sides, which is a finite and the non-zero. Thus, by the limit comparison test, this behave A-like, but clearly says that this series is convergent by using the P test, because P is my 2 which is greater than 1. So B is my convergent, therefore An is also convergent. Look about this one. So again, what is a Bn is, if you take n in the here, and in this case it is a n cube, so it is 1 by root n. Now find the ratio of the An upon Bn. You will get as a non-zero finite number. It means An and Bn behave A-like, but it clearly says that this series Bn, that is n raised to power half, which is less than of the 1, hence it's a divergent. Therefore the series is also divergent. Look about this one. So if you consider this is my An, if this is my An, what will be my Bn? So if you consider what is the Bn, so if we say it's a root, what is the highest power of the n in the numerator is, that is root of the n, and highest power of the n is n root n. So clearly say that it is 1 by root n, so it will be cancelled out. So Bn is my 1 by here. Take the ratio An upon Bn. This I can write this number as here n root n plus n over this. Now clearly say that again it's an infinity by infinity form, so you can divide it both sides by n root n, so it will be my 1 by root n, 1 plus 1 by n root n. So this will go to the 0, this goes to the 0, so answer will be my 1, which is the non-zero and the finite number. So it means both the natures are same. Can you say what is the nature of this? It is nothing but n raised to power half. So by using the P test, we can say P is less than 1, so it is a divergent. Therefore series is also divergent. In this example, you have to find the value of the Bn. So what is the highest power of the 1? N is, that is a 1. In the denominator, it is a multiply sign, so it can be written like here. So this is my Bn. Otherwise, you can also open the expansion of the tan x. You can try to open this x minus x square by 3 x square by and so on. So you can open this, but there is no need of that. Take the ratio. So we all know that tan of x divided by x as limit x approaches infinity is nothing but my 1. So if I write this quantity as of this form, this x by x is a 1. So it means both the natures are same. So what is the nature of this? So this is a convergent series because P is nothing but 3 by 2. I can write this number as 3 over 2. So by the P test, it's a convergent. Hence An is also convergent. Look about this one. So if this is your An, how you find the Bn? So what is the highest power of the n from the numerator? So it consists of only 2 raised to power n. In the denominator, it's a 3 raised to power n. So I can write this number as 2 over 3 is 2 by 3 raised to power n is Bn. Now take the ratio. You will get the as a 1, which is a non-zero and finite. So it means what can you say about this series? So this is my convergent or divergent. So clearly says that this is not in the form of 1 raised to power n p. It means P test is not applicable. So you can apply some another test which is the form of the geometric series. Geometric series is convergent when mode of R is less than 1. So which is a less than 1. Therefore An is also a convergent series. Look about this, how you find the value of the Bn. So what is the highest power of the n? Because it's a product form, it is here and divided by here. So it is n root n is my Bn. Now you can take the ratio of this, you can take An upon Bn, you will get as here. Now what is that? It means what is the value of this? This is n raised to power 3 by 2. But we always need 1 over n raised to power p. So how you write this quantity in terms of 1 over this? So I can write this as minus 3 by 2. So minus 3 by 2 is less than of the 1. So it is a divergent series. Look at the another one. Now that is a very interesting question are there. So whenever there is a question of the log of n, so we always know that this quantity is a 0. But the question arises is, look at that. This is a numerator, this is the numerator, that's fine. But here is a power is changed. How you compute 3 by 8? So if I tell you the general rule, if it is a p by q, then in order to this you have to find as a 2q q minus p. That is a simple rule about, sorry, it's a p minus q. This is my p minus q. So clearly say that in this form p is my 7, q is my 4. So you can say 7 minus 4 divided by 2q. So that's the power of this n raised to power 3 by 8. So as we know, if you take as n approaches infinity, if you take that L'Hopital rule, it goes to the 0. What is the meaning of that? It goes to the 0. It means there exists some number n so that it becomes a less than 1. But our target is to find the convergence of this series. So what you can do, I can firstly find the value of the log n from here. This is nothing but n raised to power 3 by 8 for all n which is greater than or equal to m. Now I can divide it both sides by n raised to power 7 by 4, n raised to power 7 by 4. Because n is my natural number, so n raised to power 7 by 4 is always be a positive value. So which is here. Now you can apply the limit comparison test. What is that? This is in the form of 1 by n raised to power p. So you can take this as a convergent series because p is my greater than 1. Therefore, this is a convergent. So any question which is related to the log of this, you always start from here. Like if I will tell you in the exercise problem, say this is say 31 n raised to power 5 by 4. So how you can do that? This is my p by q. So it is 8, 5 minus 4. You can start from n raised to power 1 by 8. Okay, so this is the root of this. So firstly you can rationalize them. How you can find the value of the bn? So highest power of the n is here. So in this case it is a root of n from here. Root of n is there. That is 2 root of n. So 2 is a constant number. So there is no need of this one. Now take this ratio. You will get a non-zero and a finite number. But this is a divergent series because p is my less than 1. Look about this one. So here you can see the nth term is not given to you. But how you can find this an firstly? So you can see this is 1. This is a 1, 2, 3. It's a 2, 3, 4. It's the second term. It starts from the n. Then n plus 1. Then n plus 2. This is the nth term of the series. Can you find the value of the bn? 1. Because this is the product form. So the product is my n from here, n from here, n from here. It's a n cube. Now take the ratio. You will get the answer as 1, which is non-zero finite, but this series is my convergent because np is my greater than 1. So series is also convergent. How you write this series here? The first term is start from the 2, then 3, then 4, but 1 is not be there, so I can start from here. This is the first term is 1, then 3, then 5, then 7. That's the odd series. So it's a 2n minus 1 raised to power k plus it's a 3, it's a 5, it's a 7. So if 1 and then 3, so I can write it as of this form. So but what is the value of the k? It means depending upon the value of the k, we will get the convergent. For some value of the k, we will get the divergent series. So our target is to find this value of the k. How you find? So firstly you can find the value of the bn. What is the highest power of the n in the numerator? That's n cube. Highest value of the n from here, this is the n raised to power k. So this is my bn. That is, I can write this as 1 upon k minus 3. Now you can take the ratio. I can write this number as nk separately and n plus 1 cube, and this is n raised to power minus 3 I can write here. So I can write like this. Take n approaches infinity, this goes to the 0, this goes to 0, this goes to 0. So it is 2 raised to power k, 2 raised to power k of 1, that is 1 upon 4 raised to power k. So what is the nature of this? So it will be convergent when k minus 3 is greater than 1, k minus 3 less than equal to 1 is a divergent. So therefore the series is convergent when k is greater than 4 and divergent is a less than equal to 4. Again look about that. So this is square root of them. Whenever there is a root of the terms, always you have to rationalize them. So you can firstly find the rationalization of the an. What is the bn? 1. Highest power is my n square. So root of the n square, that is 1 over n, is my bn. Find the ratio. You will get as a 1, which is a non-zero finite. This series is my divergent because p is my 1, which is less than equal to 1. How you find the bn? Highest power of the n in the numerator is n square. Denominator it's complete itself. So it will be my 1 over n root n is my bn. Now find the ratio. Take the ratio. You will get the answer as 7. So but what is the nature of this? I can written this as 3 by 2, which is a convergent series. Look over this one. Again in this case, what is the value of the p? What is the value of the q is not given to you. It means you have to find the conditions on the p and q to check the convergence. What is the bn according to you for this example? What is the highest power of the n? In the numerator is n raised to power p. In the denominator is n raised to power q. So my bn is q minus p is my bn. Now take the ratio, which is a finite and non-zero. So depending upon the nature of this, whether q minus p is greater than 1, then convergent, otherwise divergent. Now how you find the value of the bn from here? So it is not possible because of this minus. In the numerator you can say 1, but what is the denominator? So it is a n, but if you expand them, what is the series of the log 1 plus x? This is x minus x square by 2, x cube by 3 minus so on. So it will be 1 by n cube and so on. So you can't find the largest power. What we can do, we can expand them. Now you can find the value of the bn. So that is the first term is always my bn. Because it's an infinite series, you are unable to find the largest power of the n. So you can take this as a smallest, the first term, that is 1 by n square. Now take the ratio, you will get as a finite number. But this series, you can say this is a convergent by using the p test, because p is my 2, which is greater than 1. Look at the last examples are there. So how you find the bn from here? So largest value is n square, denominator is n cube, so it will be 1 by root n. So you can find it, and which is easily a divergent series. Now for here you are unable to find the value of the bn. Why? Because in the denominator it is fine, but what about the numerator? If you expand the value of the cos of the n, it will be n minus n cube upon 3 factorial, sorry, n square upon 2 factorial and so on. This is one, that's a series of the cos x, but this is again you are unable to find that. So what we can do, we will see cos of n is always with the bounded, because it's a mode of sign, so it's always positive. Now we can divide it each term by n raised to power 4 by 3. What is that? Now we can take the summation on each term. We can take the summation, it will be an, and here. What is that? We can apply the p test, which is a convergent because p by 4 by 3 is greater than 1. Hence, the series is convergent. This is the way you can solve this limit comparison in the p test. Few questions are exercise for you. These are the 6 questions and answers are there. You can do it yourself. Other questions are there. You can take more 7 questions. So total 13 questions. These are exercise for you. Check whether you are able to understand this lecture clearly or not. You can see this is the series of the log. This is the n and so on. I hope you can simply enjoy this session. We will see the next lecture on the Cauchy ratio test for the infinite series. Till then, you can simply like, share and comment on these videos. Best of luck students. Happy learning.